When you write Java code that talks to a database, calls a remote API, or reads from a file, you are almost always waiting. The thread executing your code just sits there, blocked, doing nothing, while the operating system waits for bytes to come back from a disk or a network. For decades, the only Java tool for this was Future. You submitted a task to an executor, got a Future back, and called get, but get blocks. And if you had 5 tasks that each depended on the last, you had 5 blocking calls stacked in a row. CompletableFuture arrived in Java 8 to fix that. It lets you describe what you want to happen after each step completes without blocking a thread to wait for it. This video explains exactly how it works, why it was designed the way it was, and when you should actually use it. Think of a future as a promise, a placeholder that says a value will be here eventually. Java's original Future, introduced in Java 5, gave you 2 options. You could call get immediately and block the calling thread until the result arrived. Or you could poll is done in a loop, which is just busy blocking with extra steps. There was no way to say, when this finishes, run this next function. You had to wait for the result and then write the next step yourself in sequence on the same blocked thread. This is fine when tasks are independent. But the moment you need to compose results, chain calls, or respond to failures with alternative logic, classic Future forces you into deeply nested callback hell or sequential blocking. CompletableFuture was designed to escape that. CompletableFuture is both a future and a completion stage. The future side gives you the result when it is ready. The completion stage side lets you register callbacks that run when it completes and chain them into a pipeline. You create one with supply async, passing a lambda and optionally an executor. That lambda runs on a thread pool thread, typically the ForkJoinPool common pool by default. The calling thread does not block. It immediately gets a CompletableFuture object back. When the lambda finishes, the CompletableFuture transitions from incomplete to complete, and any callbacks registered on it are triggered. The key insight is that the callbacks are not run by the thread that registered them. They are run by the thread that completes the future, or by a new pool thread if you chain with async variants. The 3 most important composition methods are thenApply, thenAccept, and thenCompose. ThenApply is like map on a stream. It takes the result, transforms it, and returns a new CompletableFuture with the transformed value. The original value is unchanged. thenAccept is the terminal consumer. It takes the result and performs a side effect but returns a CompletableFuture void. thenCompose is the flat map equivalent. If your transformation itself returns a CompletableFuture, thenApply would wrap that in another CompletableFuture, giving you a nested future. thenCompose unwraps it automatically, flattening the chain. Use thenApply for pure transformations, thenCompose when your next step is itself asynchronous. Getting these 2 confused is the single most common CompletableFuture mistake. Every method on CompletableFuture has an async variant, thenApply async, thenAccept async, thenCompose async. Without async, the callback runs on whatever thread completed the previous stage. This could be a pool thread from your executor, the ForkJoinPool common pool, or even the calling thread if the future was already complete when you registered the callback. With the async variant, the callback is always submitted to an executor, giving you explicit control over which thread pool handles each stage. This matters for IO-bound versus CPU-bound work. You want IO-bound tasks on a thread pool sized for blocking. You want CPU-bound transforms on a pool sized for cores. Mixing them on the same pool is a correctness problem disguised as a performance problem. Combining multiple futures is where CompletableFuture really earns its place. thenCombine takes 2 futures and a function and fires the function when both complete, passing both results. allOf takes a variable length array of completable futures and returns a new one that completes when all of them do. allOf returns CompletableFuture void, not of the results, so you need to call join on each original future after allOf completes to collect the values. anyOf is the complement. It completes as soon as the first of its inputs completes, returning the result of whichever finished first. This is useful for redundant requests. Fire the same query at 2 replicas, take whichever answers first. Error handling in CompletableFuture uses 3 methods: exceptionally, handle, and whenComplete. Exceptionally is the catch block. It fires only if the future completes with an exception and lets you return a fallback value. Handle fires unconditionally, receiving either the result or the exception, one of which will be null. It is both the happy path and the error path handler in one callback. whenComplete is similar, but it cannot change the result. It is purely for observing completion, like logging. A critical subtlety: exceptions in a CompletableFuture do not propagate automatically to the calling thread. They are trapped inside the future. If you never call get or join and never attach an exception handler, the exception disappears silently. Always attach at least an exceptionally or handle at the end of every chain. The threading model has one trap that catches most developers. If you do not provide an explicit executor to supply async or the async stage methods, CompletableFuture uses the ForkJoinPool common pool. That pool is designed for CPU-bound non-blocking work. If you put blocking I/O into it, for example a JDBC call or an HTTP request, you are blocking threads that the entire JVM shares. Under load, you will starve the pool and hit massive throughput degradation. The fix is simple: always pass your own executor. Create a dedicated thread pool for IO-bound work using executors. New fixed thread pool or a virtual thread executor in Java 21. Pass it explicitly to every async call in the chain. Thanks for watching.